Bright Tuty. Every student matters.
By considering their position in the periodic table, which one of the following would you expect to have maximum metallic character? Now, metallic character is based on the ease with which an element can lose an electron. So, the easier it is for an element to lose electron, the more metallic is its nature. Now, we know that beryllium lies in group 2, and it is separate from all these, which are in fact non-metals or metalloids. So, this is the only metal rather here. Gallium also behaves in similar way, but beryllium would be more metallic than gallium. So, metallic character decreases by moving from left to right on the period. Thus, beryllium is the most metallic, as it is left on the second period, and selenium is a non-metal, as it is rightmost in the third period. Thus, beryllium is the most reactive and beryllium is the least reactive. Which of the following statement is not correct about the trends when going from left to right across the period? So, when we go from left to right across the period in the periodic table, the elements become less metallic in nature. This is true. So, we have to find not a correct statement. So, this is actually true, and that is why this is not the answer. As you go, here we have 1 or 2 electrons in the outermost shell, and here you have 6 or 7 electrons in the outermost shell, which means the metallic character or the ease with which an element would lose electron would decrease. So, the elements become less metallic. The number of valence electrons increases. Now, the number of valence electrons increases. That is also true. As you see, from 1 it goes up to 8. So, the number of valence electrons is in fact increasing. The atoms lose their electrons more easily. Now, you see that here we only have 1 electron, it would be easier to lose it. But losing 7 or 6 electrons is difficult. So, this is in fact not true. This is our answer. But still, let's read the final one, that the oxides become more acidic. Now, we know that the oxides of non-metals are acidic in nature, and that is why oxides would in fact become more acidic as we move on towards the non-metallic side of the periodic table. So, the answer is C, because atoms lose their electrons more easily is a false statement, and all of the other statements are correct. Element X forms chloride with the formula XCl2. So, what we can derive from here is that since Cl has a valency of 1 minus, X must have a valency of plus 2, then only would it form XCl2, which is a solid with a high melting point. So, which is a solid with a high melting point suggests it has metallic nature. X would most likely be in the same group in the periodic table as. So, for something to have a valency of 2 but as well as be metallic, so we will rule out sodium, because sodium has configuration of 2, 8, 1, which means it has 1 electron in the outermost shell. So, this is not the answer. Aluminium has the configuration of 2, 8, 3, which is again not the answer, because we need 2 electrons in the outermost shell. Silicon has the configuration of 2, 8, 4, again not the answer. But magnesium has the configuration of 2, 8, 2. It has 2 electrons in the outermost shell and hence the valency of 2. So, the XCl2 is actually MgCl2. And by this we will answer the question that magnesium has the valency of plus 2, and that is why it is forming a compound with chlorine of XCl2 format. Which element has 2 shells, both of which are completely filled with electron? So, we need to have 2 shells. So, we have K shell and we have L shell. Both of them are filled. So, for K to be filled you need 2, for L to be filled you need 8. So, the atomic number becomes 10, and the atomic number 10 is of neon. So, the answer is neon. You can write the answer directly or show the configuration to get a clarification. The electronic configuration 282. Now, 282 means atomic number of 12, which means the answer is magnesium. As we did in the previous question, the atomic number of magnesium is 12. A total of 3 shells in which 4 electrons in the valence shell. So, for an element to have 3 shells, we have K, L, M. the first shell will have to be full and the second will also have to be full. Third is it stays here as 4 electrons. So 284 means 14, and 14 is the atomic number of silicon. So the answer is silicon. A total of 2 shells with 3 electrons in its valence shells. So again, 2 shells, so means K and L only. We have 2 electrons in the K shell and 3 electrons in the outermost shell. So 2 and 3, which comes up to a total of 5, and the answer is boron. Boron has atomic number 5. You need to remember the atomic number of elements up until 20. That is essential for you to answer these questions. Twice as many electrons in the second shell as in the first. Now you know if there are 2 shells, the first would have 2 electrons. So we have K, we have L here. It would always be 2 for the shell would have to first fill up. So it says double the number here. So what is the double of 2? 4. So we have 4 here. So 2 and 4, the total becomes 6. The atomic number 6 is of carbon. So carbon is the answer for the final portion. Twice as many electrons in the second shell. So don't get confused by these wordings. You know that the first shell would have to be fully filled to get to the second shell and then to the third shell. So just keep on adding the elements and you will understand what is the atomic number, and from the atomic number you can derive the name of the element. What property do all elements in the same column of periodic table as boron have in common? Now all the elements which lie in the same column as the boron belong to group 13. Therefore, they have 3 electrons in their outermost shell, all of them. So they have different number of shells, but they all have 3 electrons in their outermost shell, and that is the property which runs. That is the property which would be true for all columns. Columns are the groups. So what are the properties of all elements in the same column in the periodic table as fluorine? Again, column is a group and all the groups have the same number of valence electrons. The elements which lie in the same column as fluorine are called as halogens. That is because they belong to the group 17, which has 7 electrons in the outermost shell and thus has a valency of 1. So fluorine has configuration of 2, 7. It needs to gain 1 electron from somewhere to get a stable octet, and that is why it has a valency of -1. So all the elements in the same column is the group, will have the same chemical properties, the same number of valence electrons, and all the elements in the same row, which is the period, would have the same number of shells. Now let's move on to the next question. An atom has configuration 287. Since it has configuration 287, the total becomes 17. Now can you identify the element? The element is chlorine. What is the atomic number? Atomic number simply is by adding these numbers. So 2 plus 8, 10, 10 plus 7, 17. So the atomic number is 17. To which of the following elements would it be chemically similar? Now let's see what is the configuration of these elements. It has nitrogen, has an atomic number of 7. So it means it has 2 and 5 configuration in KLN shell. Fluorine has atomic number 9, which means 2 and 7. Phosphorus has atomic number 15, which would suggest 2, 8, 5 configuration. And then finally we have argon with atomic number 18, which would have 2, 8, 8 configuration. Now based on this we have to find chemically similar. Chemically similar means something which has the same number of valence electrons. So we want something with 7 electrons in the valence shell. Since fluorine is the only one with 7 electrons in the valence shell, fluorine would be the answer. So fluorine, because it has 7 electrons in the outermost shell with 2, 7 configuration. So based on this configuration, you can easily find out which is the element that has chemically similar properties, because the number of electrons in the outermost shell determine the chemical properties. The position of 3 elements A, B and C in the periodic table are shown below. So we have this arrangement. State whether A is a metal or a non-metal. Now A lies in group 17. It means that it is highly electronegative. That is why it will be non-metallic in nature. State whether C is more or less reactive than A. Now for non-metals, as you can see that when they go down the group, try to get the answers, when they go down the group, the non-metallic character would decrease because the atom becomes bigger, right? So as we go down the group, the atom becomes bigger, and that is why the pull that it exerts on an outer electron is lesser. So this would pull an outer electron with much stronger force as the nucleus is closer to the outer shell, whereas here the force would be relatively less. And that is why as we go down the group, the elements become less reactive, and that is why C is less reactive than A. So here we have the answer as C is the less reactive element, because in metals, although when we go down the group the reactivity increases, but in non-metal it decreases. Will C be larger or smaller than B? Now when we go across the period, the pull of the electrons in the outermost shell shrinks the atomic size, right? And that is why C would be smaller than B in size. Which type of ion or cation will be formed by element A? Now element A is a negatively is an electronegative element, and that is why it would form an anion with a valency 1. So that is the answer for this part. A will form a negatively charged ion with a valency of -1. And let's move on to the next question. So nitrogen with atomic number 7 and phosphorus with atomic number 15 belong to group 15 of the periodic table. We write the electronic configuration of these two elements. So as you've seen here that 7 would be divided as 2 and 5 in K and L shells, and for phosphorus again it would be K, L, M shells with 285 configuration. Which of these will be more electronegative and why? So nitrogen has 2 shells, and that is why it will be more electronegative, because it can easily gain the new electron. It can easily it will exert more force as the nucleus is closer to the outermost shell, and it will be able to capture the electron quicker. So because it can easily gain electron due to its small size of the atom, nuclear charge attracts the electron easily to become a negative ion. So the idea here is that when you're talking about non-metals, as you go down the group, the reactivity decreases, and the more the element on the top, the more electronegative it would be. How does the electronic configuration of an atom relate to its position in the modern periodic table? Now we have to tell how is the configuration positioning the atom in the modern periodic table. So we have 2 elements, we have the period and we have the group location. So the position depends on the electronic configuration. The period number comes from the number of shells in an electron. So if it is 1 shell, then it is in the period 1, if 2, then in the period 2, and so on. The valence electrons decide the number the element will have in the group. So if an element has 1 electron, it will be in the group 1. If it has 2 electrons, it will be in the group 2. But for every subsequent group, we add 10. So that is how it works. So for our understanding, we have elements for group 1 and 2, we write directly the number of valence electrons will be equal to group number if it is 1 or 2, but if it is more than 2, if it is 3 and above, it becomes the number of 10 plus the number of valence electrons. So the group becomes 13 or 14. For example, if we talk about chlorine, it has 7 electrons in the outermost shell, and this group is 17. 10 plus 7, 17. So we have 2 elements for the classification. We always use the atomic number first of all. Secondly, the 2 criteria that we have are period and the group. The period is determined by the number of shells it has, and the group is determined by the number of valence electrons. In the modern periodic table, calcium has atomic number 20 surrounded by elements with atomic number 12, 19, 21, 38. Which of these have physical and chemical properties resembling that of calcium? Now we need something which has the physical and chemical properties resembling of calcium, which means something which has the which has the outermost shell having only 2 electrons, because calcium has an atomic number of 20, because of which its electronic configuration becomes KLMN shell of 2882. Now we need 2 electrons in the outermost shell to achieve a similar structure, to achieve similar chemical and physical properties. Now 12 would be 2, 8, 2. You will not be able to solve the higher elements because they have separate rules, but 19 would be 2, 8, 8, 1. 21 would be 2, 8, 8, 3. So 38 will have separate rules, and that is why I am not solving it here. In fact, this also shows separate rules, but you can understand just from the first one that 2H2 which is 12 atomic number, which is magnesium, would show similar physical and chemical properties. Element 21 in any way would have one electron more in the outermost shell, and that is why it will definitely not show similar properties, and neither would the element with atomic number 38. So elements with atomic number 12, 2H2, and atomic number 38, which has 2, 8, 8, 18, 2. So I did not explain this. I cannot explain this because it has a higher understanding that you would need to have. But what you can understand is that 38 electronic number has 2, 8, 18, 8 and 2 configuration. This is something that you will have to remember, and this configuration works in a separate way. But again, I'm sorry, let's go back to it. So we have 12, 19, 21 and 38. We cannot, these we know that are not the answers, and element with atomic number 12, which is magnesium, we know is the answer, and for 38 you will have to remember the configuration to understand it. So these two will show similar properties because they have same number of electrons in the valence shell. Now the final question is, compare and contrast the arrangement of Mendeleev's periodic table with modern periodic table. So in Mendeleev's periodic table, the criteria was atomic mass, whereas in the elements of modern periodic table, the criteria is atomic number. So they are arranged in the increasing order of atomic mass, whereas here they are arranged in increasing order of atomic number. There are a total of 7 groups and 6 periods, whereas here we have 18 groups and 7 periods. Elements having similar properties were placed under one another. Elements having same valence shell are present in the same period, while elements having the same number of valence electrons are present in the same group. So that was the criteria, the way in which the classification worked. Position of hydrogen could not be explained here. It was a big doubt in that table, whereas here it was sure that it would be placed in group 1, period 1. No distinguishing position for metals and non-metals. Metals are present in the left hand side of the periodic classification, whereas non-metals are present in the right side. So the modern periodic table corrected many errors of the Mendeleev's classification because it changed the criteria to atomic number, and that is why we have this all these problems which were resolved in the modern periodic table. So that is all for this chapter. Thank you.